Okay, thank you. Thank you both. Great presentations. I've got a question about the semantic layer, which I'm also a fan of, using DBT, and yeah, I want to declare some of those things. I think it's the problematic thing is mostly about the governance, data governance, which is actually semantic layer is an output of.
Yep.
So now the question is how to convince business to spend actually money on it, because business usually thinks that governance is just useless. And then how do we actually potentially utilize AI to help make this decision, to speed it up, so we can automate a lot of this work, because we know that there is hundreds, even thousands of KPIs across the company. Various systems, governance is hard part to do. So how do we approach it so companies are more convinced to do it?
Yeah, thank you. I will repeat the question for the benefit of the recording. So, well, yeah. So very shortly, so he recognized the importance of the semantic layer, but one of the problems that always come up is basically what's the business kind of like business case for the semantic layer. How can we convince business in invest into it? Usually it's a governance problem. So you really need it's a data governance problem, and a lot of business don't really want to invest in data governance because the ROI is not clear. All right. So that's very important, and that's basically my job. Because it's can you tell me how much incremental revenue this semantic layer will bring me? And say, does it really work like that? It's more of I would say a CapEx investment, right? More than a kind of marginal revenue kind of investment. What I say is there are a lot of things you can do once you have the semantic layer that will bring you money. And we can map them out for you. It's like buying if you are a manufacturing business, it's like buying a new plant to put the machinery to then make money, right? If you don't buy the plant first, you won't have any money. And that's how I explain data governance. So I say, let's say, for example, you are a fintech, right? One of my clients is a fintech. And they want to build a text-to-SQL analyst to build a sort of AI companion where their customers can say, oh, how much I spent on coffee last week? This kind of stuff. And I said, okay, cool. How much revenue do you think this feature will bring? I say, oh yeah, we are expected to make, let's say, 10% of our revenue on the margin with this feature. Okay, how much is that? Say, this much. And I say, without the semantic layer, you are making zero because this is not going to work. So this is a prerequisite to then make money. It's a CapEx investment, it's not OpEx. That's how I usually put it, especially if you're talking with finance people, because you are talking their language. And also the CEO will talk that language. Now there is another problem, which is people, like data governance and bringing people together. That's basically an incentives problem that you need to solve. So usually you need a lot of people in very big organizations to collaborate to the semantic layer, because they will need to tell you, okay, this is what this metric means, or this is what this data means. And they don't have a lot of incentives if you don't show them. And so you need basically to understand what are the incentives to basically pull on them. Usually it's something oh, do you want to automate data reporting or some kind of quick analysis that we could do with an AI agent on top of that? If you want that, you need to help me do the semantic layer. So classic example, an operations team that complains that the data science team is always busy and they don't have time for their requests, they want to self-serve. Say, cool, if you help us build the semantic layer, we can build an internal AI agent, or just use Looker AI agent to answer your questions so that you don't need to go to data. Are you up for that? And that usually aligns the incentives.
Yeah, I've got a question about the DSPy optimization. So the question simply is, how do you stop the output of the optimization turning into some huge mega system prompt? And the reason or the context of that is the example you gave is quite trivial, so it's highly likely that real world example is going to be a lot more complex prompts. You also mentioned that you had something that was running for 16 hours, cost you $800, so cost could be prohibitive. Also, in my experience, when you're developing products, your evals could change over time, and the prompt that you need would change, so then you'd have to run that optimization several times. So how do you stop it from exploding in size, and how do you control the costs?
Yeah, that's a really good question. So just for the recording again, the question was really like, how do you stop this becoming a monster, right? Like, so we talked about how it cost $800 for me to run that one optimization for 16 hours. And also the prompts that you get out can sometimes be quite large. I thought the point was that we were trying to shrink our prompts, right, to improve the context window. So how do you kind of control for that, especially if you have to then retrain that prompt when a new model comes out or if the data changes? I would say that you shouldn't use DSPy for trivial problems. I think if you can't, if the problem's not important enough to spend $10, $50, $100 solving, then you should just, you could actually just use DSPy without optimization, and it's a pretty good default. It was 50% accurate just off the bat, right, without me having to write a prompt, which is quite nice. And quite often that's the first thing I'll do. I'll just create a credit in DSPy, see if it works. If that judge was getting 80-90% accuracy before we trained it, I wouldn't have trained it. Like, what's the point? You want to do as little prompt engineering as possible, right? And you want to do as little AI engineering as possible, because you have a million other things that you could be doing to improve the application, like front-end work. Most applications that are not trivial have more than one prompt, right? So if DSPy gets you a good outcome on 5 or 6 of those, and then you just need to optimize the really important one that's difficult, then it's worth putting a bit of extra effort into. But the nice thing is it's fine if the prompt is really long that comes out of DSPy, because it's been tested, it's been proven that it does need to be that long in order to get that high of accuracy. What the mistake I see people making is that they have these huge long prompts that have just been management by committee, and the CEO added a few lines, and like the domain experts added a few more lines, right? So it ends up becoming like a really big prompt just by lack of communication, rather than because it was tested and found that every single token counted.
Mm-hmm. Okay, and DSPy has to extend my point, basically you had a list of optimizers. So before you make a decision, you choose the right optimizer for your task. So Bootstrap, Qshot, or maybe Simba, or choose your optimizer in the first place. Like what you're doing, some optimizer need like loads of examples, and you can make that decision in advance to reduce your cost. That's one of them.
Prompt?
Sorry, just to make sure it gets on the recording as well. So because you're not mic'd up, but for DSPy you have a few different optimizers you can use. Like I use GEPA quite a lot, but there's a few smaller ones that do less work, and could work pretty well out of the box. You also can control the parameters. So I set the parameter to just do one max eval loop with GEPA, but you could set that to 10 or 100. For that task where I spent $800, it was because we were going to be using that prompt to simulate 5,000 AI marketing personas in order to ask some really important questions about marketing segmentation for a credit card company. And that credit card company would normally spend $100,000 to do that survey. So it's totally worth 800. Yeah.
Thanks for the presentation, very insightful. I've got 2 questions aimed at. So first question is really quick, which is around the out-of-sample accuracy for the classification. Was that out-of-sample or was that in-sample, the 88 or 89% you mentioned?
Yeah, so the question was the sample accuracy that I quoted, was that in or out of sample? So if you remember at the beginning, we separated out the training data set, the test data set, and then the development set. So that one was out of sample. We held that back, yeah.
And this is a question for yourself. So what you presented is interesting, and giving the agent some context in terms of how to answer a question. So typically for, say, a data scientist, imagine I'm a data scientist and the CEO will come up to me and say, okay, can you tell me last year how much of your revenue was driven by pricing versus marketing? as a data scientist, a quick answer, I'd probably go off and run a quick correlation in revenue against marketing spend or pricing, and then give it a quick answer. Well, the estimate is this, but it's not really scientific, but just quickly. How would an agent go about answering that question?
Yeah, okay, does it work? Yes. So the question is, how does an agent go beyond pure data retrieval question, which is, what's my revenue yesterday, to causation questions? What is driving my revenue increase or decrease? That's kind of like spirit of the question. So the semantic layer is not enough. It's the starting point there. So first of all, you want that your agent retrieves the right data to get that answer, to run that correlation. And probably you need to build a much more complex system, I would say multi-step system, that has a component that is a sort of like causal analyst agent in that, right? So here, what I would try to do, just on the top of my head, is try to break down your task in subtasks and have one agent for each of those tasks. So the first agent, so to answer your question, like let's say that you want, first one agent that tries to understand what data we need, and that's one agent. That you want one agent that goes to the semantic layer and pulls the data that we need. That's the second layer. The third layer is someone that does the job, so runs the correlation, and maybe you want also a storytelling agent. So if you try to do it one shot, it's probably not going to work. What I would do is try like to break it down in different steps, and I just gave you like an example that I just made up right now, but I think that's the way to go. When it comes to the role of semantic layer in that, again, if you don't price, what's price? All right, where do we have price in our data warehouse? What's revenue? Where do we have revenue in data warehouse? That's where you have to have mapped those concepts in the semantic layer. Otherwise, your, let's say, data retrieval agent will try to guesstimate that. And of course, like if you have a very good naming convention on your table, it might get it right? But the likelihood of getting it right will go down, and also the consistency will go down.
Great talks. I have a question about DSPy. What's the regularizer in DSPy? How do you regularize the prompt to make sure that it doesn't do it? Is everything the optimizer?
Yeah. So the nice thing about DSPy is it's open source. So even though I actually don't understand too much about what's going on under the hood, they've written papers about it, and you can dig into the code yourself. So it depends on the optimizer. But broadly speaking, all the optimizers will have a test set and a training set separate. So your question was about regularization, and basically like, how do we make sure we're not overfitting on the training data? The optimizer itself, doesn't peak, right? Like it does the tests and then fixes it. Typically, what they would recommend is you would also keep another 20% behind, just as the validation set. So that's what I did in mine. Like I kept it, and that's something the optimizer hasn't even seen. So even if there was some contamination, you can really prove that you have actually learned how to tell a funny joke, not just learned how to train on those specific jokes. And one thing I do sometimes with my clients to really, make them trust the result is I tell them to keep a data set and don't even send it to me. So you know that I didn't peak, right? And I haven't put anything in the instructions from that data set. So you can have this extra layer of kind of holdout where you run at the very end once you're confident.
I'm hoping to get some guidance on, so I've seen a lot of examples, and thank you for the example today for DSPy for around classification specifically, but
yeah.
I think sometimes we have issues where we have solutions that we want to generate output from, we've got some log files, we're reading log files and getting some meaningful insights out of them. Is there what kind of optimizers or what kind of strategies can you use to help evaluate, or rather what kind of evaluators can you use to evaluate the output that's coming out? Because it's not like a label, it's not like so straightforward.
Yeah, so your question was how do you, DSPy, there's a lot of the examples of classification problems, which actually are relatively straightforward, and DSPy works really well for classification problems where you're like, okay, I want to label this whether it's good or bad, right, or funny or not funny. My trick that I showed today for solving a problem, the wider problem, which is, okay, what happens if it's not a simple classification problem? What happens if you need to write a report? And a report could be graded in lots of different ways. Like, the CEO likes the reports to be concise. So now you have to create a concise metric. How do you measure concise? Is it just word length or is it word choice? It starts to get really difficult when you have to formalize the metric. So my hack here is, which I showed today, is to train a judge first. The judge is the classifier, and then use that classifier as a DSPy metric for the original task, right? So hopefully, in that example, it comes across well. But every task is eventually a classification task if you go far enough down the branch, and so you just need to kind of roll back up and say, there might be a lot of different things that you classify in that report that you're writing. Conciseness, etc. And quite often my actual evaluation metrics that I use in production is not just even one simple LLM judge, it's a panel of judges. I have one judge which tells me, is the joke like racist, right? Like have another, because I don't want that, right? It depends on the audience, I guess. No. You have another judge which is like, is it in the right style of the comedian? I have another judge which is like, is it on topic? So you can actually add a lot of these together and then have some sort of weighting within your evaluation metric as well, and say, okay, like here's the broad basket of things that I'm looking for.
DSPy, really interesting. If I understand it right, it's almost like brute forcing for a prompt. And that sounds really interesting in a jailbreaking context. And I wonder what that means for safety. And I'm curious if you're aware of that.
Yeah. So Tom, I knew you were going to ask a jailbreaking question. It's that sort of guy. No, ethical, no. So the question was, it looks a bit like DSPy is brute forcing the prompt. And that kind of made him think about jailbreaking. Like, you could kind of keep testing and testing and testing until the LLM kind of passes the,
or even general security.
Yeah, or even general security, right? Actually, the nice thing about DSPy is not just brute forcing. It depends on which optimizer you use, but it's doing it token efficient. It's making as few calls as possible. Like the GEPA one is like an evolutionary algorithm where it kind of grows different programs and then drops the ones that don't work. But then there's a Bayesian one, which is MePro, which kind of weights the probabilities of different strategies working based on, it tests maybe, let's say, like 3 examples. And if it works on 3 examples, there's a much higher probability that it'll work on more examples. So rather than testing on your whole database, test on 3 first, test on 5, test on 10, etc. So they've done a lot of really cool work to make it even more token efficient. I haven't seen people openly talk about using DSPy for malicious purposes. But like any good tool, I guess it can be. Actually, they do have a tutorial where people use it for guardrails, the opposite side of prompt injection. So if you have an application that's open to the internet, people will try and trick it to doing stuff. People will try and ask for personal information to be sent back. That's a pretty big threat vector, actually, if you work in cybersecurity. That I feel like that's going to be the big thing over the next 10 years. But like DSPy, you can actually use it to train the guardrails. So you can train it on here, like a list of 100 malicious prompts that users have sent. Let's see how many of them it actually shares the password and how many of them it doesn't share the password.
I have 2 questions. Sorry, one for Leonardo and one for Mike. Thank you very much for coming, guys, today. First of all, definitely, meeting people who are building is much better for all of us in the community than the people who just bragging, hyping, and.
Yeah, we're hyping as well. Yeah. But, we are also building.
Leonardo, so you showed that the query against SQL was like happy 50%, 54%.
Yeah.
Even if that goes to 80, in mathematics is still pretty bad. So would we not try first yet to advise using maybe MCP to do a bit calculation, which we know they will
Yeah.
Joe, that's the question for you. And Mike, you said that your first or second highest pay employee is OpenAI.
Yeah.
Which I guess can guesstimate will be somewhere in a range of 80K per year. Would you think that spending this money on running your own infrastructure, even for the real experiments like that, will be much more efficient than paying the big guy and just spending too much? I'm saying that
Do you want to do yours first, or?
Yeah, I can do. So the question for me is basically, with the semantic layer we've seen in the paper, we get to 50% accuracy, which is bad. And like the suggestion might be, oh, why don't we use MCP? I guess the answer there is, it depends what the MCP returns and what is built on. Like, I would also consider eventually the MCP as a sort of like semantic layer itself, right? You plug into some sort of like well-defined data, and if you have like well-defined metrics in the MCP, and that's how the MCP has been built, like the Stripe MCP being one of them, very good. Yeah, that would work, but you limit like the number of questions that you can ask eventually. So that's one part. The other part is, no, I think like that's the main idea. I've tried and I've seen people try to do both ways, but it still like depends what's kind of like the granularity that you get, like it's your data.
It's a computation, right?
Yeah.
They compute, because you don't know if the tokenizer just went to sleep and half of the data is just off the roof, right?
Yeah, you don't have like the context on that anymore. So that's one side, and the other side that I didn't want to forget is. No, I forgot about it. There was another important thing I wanted to say. Maybe it will come back. It will come back after the question with Mike.
After a couple of beers, he'll remember. No, you don't drink. Yeah. So the question was, why am I spending so much money on OpenAI, versus say like using an open source model, something cheaper? To be honest, I think people are massively underspending on AI. It's a PhD in your pocket, right? Like it can pass the bar exam. I can't pass the bar exam. The work it's doing is much better than the work that I would be doing. And so I think it's severely underpaid. It's not just OpenAI, like spending thousands a month, but like I spend the same amount on Google and Anthropic as well on top. Plus I have the $200 Cursor subscription. I have everything, right? Like literally, like my whole budget is like AI and then some food, pizza, because it's a ridiculous opportunity that we have right now. We have like intelligence on tap, and with a little bit of extra effort, you can get it to actually be very, very good at the tasks that you want it to do. So yeah, I mean, compared to like the stuff that we're doing now with just 2.5 people, like even a year ago, 2 years ago, 5 years ago, it would be the room this big. That's how much work my automations are doing for me. So like, if anything, I would say I'm still underspending. It's like 1% of the value here. Yeah. I want to spend more. I want them to give me bigger models, to spend even more money on. Yeah.
Is the half person the AI or is it actual?
No. He's I really recommend you do this. Like I know how to code, right? But I'm not like the world's best coder, right? If you're vibe coding stuff, it's really, really important that you have a real CTO, that can check your PRs and make sure. Like my job is to use AI as much as possible so that he doesn't have to do as much work, but it's still very important, I think, to have that sign off if you have real customers. Yeah. Yeah, fractional CTO. Yeah.
So we have time for 3 questions. 3 or 4 questions.
I do have like what I forgot before. So the other way I've seen people try to go around this problem is to limit the queries your agent can run, right? So I think JP Morgan has worked on an agent like that. So what you do there is that you set a given set of query templates, right? What's my revenue or what's my metric and a given set of metric in the last n days, right? Different type of questions that are most common asked. And then you have the first agent that tries to map the raw free input into one of these. And then those queries then are deterministically like match and run on BigQuery, whatever you have. Happy to talk also on the side on the MCP stuff as well. Question?
Thank you for the presentation. Question regarding the semantic layer. completely can be. Why I'm asking, because like for me, I need to figure out how system works, like new application, whatever. Yes, the first thing that comes to mind before start bothering everyone around this stupid question is check documentation, Confluence, some high level, whatever, or for example Swagger, yes, or other API documentation. Like, can this be a basically source or semantic layer? Because this data usually is up to date,
Yeah, that's so the question is how big can be the semantic layer, and what data can be basically sourced, like raw knowledge base, like Slack, maybe Notion as well, or other like documentation places, can be the source of the semantic layer? The answer is yes, and there are people, like companies, that are trying to basically build a self-improving and composed semantic layer. The problem there, like usually, is a company problem, or a people problem, and again, like the sheet data in, sheet data out. So if like the documentation, the raw documentation all around the place is not like very well defined, the agent that then needs to build the semantic layer will be confused as well, right? So what you can do, you need like to do like some curation of those sources to build the semantic layer. One exercise that a lot of companies do, like when they start a semantic layer project, is yes, let's collate the documentation that we have. And what I've seen a few times is that, oh, in this document we define revenue in this way. In this other document we define revenue in this other way. That's already a problem. So the answer is yes. Maybe you must like use like your raw source data to try to figure out everything, but then you need to agree as a company on something. Like for example, I know like I have a few friends working at Palantir. Like what they do is like a lot of this, like to build the ontology, because without that their system doesn't work. So they go around and try to define all the entities of the company, what they mean, how they work together, and try to map that out together.
Hi. As the author of the book, which section of the book are you the most excited first to read, and to which one are you the most proud of?
Yeah, okay, yeah, good question. So you said as the author of the book, what section of the book was I'm most excited about for people to read? Yeah, so actually I wrote the book very purposefully so that like you could get most of the value just in chapter 1. Yeah, actually, like in chapter 1 we talk about the 5 principles of prompting, which have remained quite timeless, thankfully. Like we wrote them back when GPT-3 was out, and then when GPT-4 came out, it still worked, and we refined a little bit, and we're like, okay, cool, this is going to be good. And then GPT-5 is out. Like OpenAI actually released their kind of principles of prompting as well, and when I looked at it, I was like sweating because it was a couple of weeks before my book was due to come out, and it was already at the printers. I was like, great, they're going to disagree with everything I said, and my book will fail. But actually, it did kind of map almost directly. They had 7, we had 5. We'd condensed it a little bit. But yeah, so I would say like they're the big takeaways. And I come from a non-technical background. Like I used to run a marketing agency, so I think it's really, really important to like get the front load all this information. So I think just reading chapter 1 in the bookstore or whatever is enough. But yeah, the rest of the book is all about how to apply that in different situations. So I think compounding that information and just trying it out. Okay, like how does it work with image generation? How does it work with creating a blog post writer? Like how do you use it with different things? But I would say actually, fun enough, like I didn't have any DSPy in the book. It came out last June. So like if I do a second edition, that's probably the main thing I'd write. I was using DSPy quite a bit at the time, but I wanted to like teach people prompt engineering specifically, like raw, how to do this without a framework. As much as possible, but yeah, that's it. But yeah, I've been back through it a few times, and it still really holds up. In fact, like we have a repo online, GitHub repo, where you can go through and see some of the examples, and literally, if you just change it from GPT 4.0 to GPT-5, it all works, and it's just that with the newer models, like it just works better out of the box with less stress, which is nice. Yeah.
Okay, we're running out of time. We're taking 4 questions. Answer it briefly. Last question briefly.
Yeah, thank you very much for both of you for a very illuminating talk. Now my question is going to be very summative actually. And I come from a platform engineering background, security engineering. Now I'm working on a recent project in which we had a change request to basically provide alternatives to search using vector search in the RAP flow. Okay, I implemented it using a framework substrate of the line flow and AstroDB. I then discovered subsequently that people who had no right or access, were accessing the live testing environment and were feeding it back to civil servants who were not supposed to know. That's because sitting test. My question is this: what is both the optimizer and the synthetic layers? How do they, at the application level, provide security and guardrails? Because what I had to do was to fall back to traditional systems administration with role-based access control. Basically changing permission files and moving the applications onto a different network segment and locking it down. Because at those layers, there was no security, there was no guardrails. Every 5 years, you have a disruptive technology that comes around and threatens the vector modeling, the vector modeling. How do you guys explain how those layers will handle that in the future?
Yeah, so if I could summarize, basically you're saying there's a issue recently where you're implementing a vector solution and it had access to, or gave access to people to data that they shouldn't have had access to, and how do you protect against that? Like, what are the guardrails in place? My answer actually with DSPy is that there are no guardrails in place, right? Like, you have to build them. At the end of the day, the prompt optimizer assumes that all the data you've given it is data that it can use. So if you don't want any leakage, I would recommend that you optimize it on a per user role level, or even a per user level. Like I do a lot of synthetic research, marketing research, so like training an AI persona based on what a real person said, so that you can keep asking questions without bothering the real person when you're doing surveys, market research. And we have a per person model. Like we actually train DSPy on each individual person in the panel because we don't want any leakage. We don't want this guy over here who lives in South London likes to cycle. Like, we don't want any leakage from that into like a different persona. It's really important, I think. Like if you're building something quite serious that you want very high performance and no kind of leakage, then I think a per person model is worth the extra cost. Yeah.
Yeah, I'm trying to think about this from the perspective of a company might want to implement this. I think one of the concerns I might have is that with so many models coming out, every month or 2 months now, that it's a little bit of a hamster wheel, and that investing in something like semantic layers and stuff like that, maybe it's not so much capex but operating costs, because you have to continue putting money into refining the model, etc. I wonder what you think about that.
Yeah, you definitely have. So the question is, given like the rate of speed that like all the models improve, we have new models every couple of months. Is like the semantic layer really capex or is more opex? Because we need to keep like changing it as a consequence of that. So I do not fully agree, because the semantic layer, the core structure will not change as the model like changes. What will change is that all other things being equal, your performance will improve given the same semantic layer, right? So let's say, for example, like you move like from GPT-4 to GPT-5. GPT-5 will still need the semantic layer to be in place to work. It's like upgrading, like in your company, you have a junior data scientist, and at some point you have the opportunity to hire a senior data scientist at the same price. You will do that. But the senior data scientist, yeah, he might be faster at understanding your semantic layer. It might be better at understanding your semantic layer. It will be, but still needs like some raw information. With that being said, I do agree that there is an OPEX component to the semantic layer, because you need to improve it. And that's where the industry is going, try to minimize that cost with self-improving semantic layers.
This is second last question, and we're taking last question.
Yeah.
Cool. Right. I'll make sure to keep it short. A question for Mike in regards to DSPy. if you were to, and I guess it links to your marketing history as well, if you were to use DSPy in the video generation space, specifically orchestrator or optimization layer, how would, for end-to-end video generation, how would that approach look like and what would be the pitfalls?
Yeah, so the question was if you're going to use DSPy to optimize video generation models, like say Google VO3 would be an example, how would that work? What are the pitfalls? One is that you better have your credit card ready because it costs like $5 or whatever per video. They just dropped the price, but it's still very expensive. For an 8-second video, it's nuts, but way cheaper than a human generated video, right? So it's still probably people are underspending. But yeah, like it works pretty well. Actually, the evaluator optimizer pattern, the first time I saw it was, there's a tutorial, DSPy has a tutorial like this as well, but there was a really old one where they just showed how you can have one LLM write the prompt for the image generator, and then have another LLM that looks at the image and says, does it match the prompt? And I used that quite a lot back in the Stable Diffusion days because that was really difficult model to get working, and it often would need a few iterations. So I was getting AI to do the iterations even back then. So it works really, really well for the use case. Specifically for video though, a picture is 1,000 words, right? Video is 32 frames per second, right? So it's 32,000 words per second, right? It's a lot. So the context window gets filled up quite quickly. You have to really break it down. You tend to get really bad performance as the context window gets too large. And then there's only really one model that works in production with video, which is the Google Gemini model. It handles video natively, otherwise, you have to do a lot of faffing around where you break it into scenes and take screenshots every 2 seconds and then send it a bunch of screenshots because the other models don't handle video. So yeah, it's a very expensive thing, video analysis and then video generation on top. But it is possible, and it's going to be way cheaper than using a creative team to do that, right? So I think it's definitely worth exploring with all of these things. If it's uncomfortably expensive today, it'll be affordable in 6 months, and it'll be dirt cheap in 12 months. So the price is dropping pretty quickly, and actually, what you don't want to do is wait 12 months, and then everyone else is doing it, and it's not cool anymore. It's not not surprising for anyone who sees it. So yeah.
Okay, sure. Thanks for the presentations this evening. Question on DSPy. And it's great that you can use LLMs as judges and this kind of stuff. But the only thing is I've just got this niggly thing about hallucinations. And I know LLMs, definitely when they're generating, that they do introduce things like you ask it to do summaries, it might substitute, it might take out King Charles and make it Queen Elizabeth, and do strange things like that. And it can't count the number of hours and strawberries and stuff like that.
Yeah.
So definitely aware of that. So I've seen figures like hallucinating up to 15% rates of that. They seem to be coming down with the GT5 and newer models. And then there are things you can do like schemas and stuff. You do extractive summaries rather than abstractive summaries. But when you move to LM as a judge, then I don't really know what the stats are like. It's not really something I've done. So you're more comfortable with LM as a judge than LM generation, and what can be some stats or figures what you think hallucination might be, and what kind of mitigations you might put in place.
Yeah, so yeah, really good question. The question is about hallucinations. So obviously we've all had this problem if we're using ChatGPT or any of these models. It does make stuff up pretty confidently, and that's also true of humans as well, right? I used to manage a team of 50 people, and tell you there's a lot of hallucinations I had to deal with. Actually, a lot more than I deal with now with LLMs. So to some degree, the nice thing about dealing with LLMs is that the hallucinations are at least predictable. You can run that prompt again and see how often it hallucinates. And then you can change some of the words and see, does that change how it hallucinates? So that's ultimately what DSPy is doing. I would have the hallucination examples in my data set and then train against that. So I'm never just trusting LLMs. And it depends on how important the task is. If it's something that you're going to be doing a task that you're going to be running 1,000 times a day or 100,000 times, then you need to know how often does it hallucinate, in what scenarios does it hallucinate, and you'll be able to track that. So I would say that DSPy doesn't completely solve that, but because it's built around this whole evaluation framework, then you can at least know how often it's happening, and you can formalize what is a hallucination and what is just it being creative. Because we call it a hallucination. Actually, literally everything it says is a hallucination. It doesn't know anything. It's predicting what is the most likely thing. And when it gets that prediction right, we say it's good. And when it gets a prediction wrong, we say it's hallucinating. But if I ask it to do a creative task, like write a poem that's never existed before, it's hallucinating that poem, right? Like you are asking it to hallucinate. It's a hallucination machine, right? so like to some degree, it is a feature more than it is a bug. So it just depends on like what is your formal definition of hallucination. If you can formalize that in a data set or in an evaluation metric or in a LLM judge, then you can catch it and you can see how often it happens, and you can see the trade-offs between which models hallucinate more, in which scenarios. Cool. All right, thanks guys. So I just want to give away the book to whoever asked the best question. Do you have any ones that you think?
It's on you, your book.
I think probably most actionable was, I think maybe it was you that asked about the long prompts, like the monster prompts. Yeah, I think that was a good one. It was very close. You were a very close second, but if you come up and give me, just DM me your details or whatever, I'll send a copy to you as well, because I thought you asked a really good question.